Morning everyone, this is logic coding. This is yet our second hard problem called merge k sorted list. If you look at the companies, like it's a very popular question, and there are a lot of concepts, and specifically regarding to priority queue and the manipulation of pointers. So it's definitely worth grinding through this question. Now let's get started. So we're given an array of k linked lists. So we have k linked lists, and each linked list is actually already sorted in ascending order, and I want to merge all of them and return a single list node. There's a very similar version with a linked list and as well as array. But like, how can we do this? So to merge sorted linked list, a common approach is to use pointers. So if we have those many lists, we assign P1 and then P2, P3. So we just loop through, like we just iterate through each linked list, and we find the smallest one. And append that to our solution, and we move the pointer. If P1 is the smallest one, we just make P1 equals to P1 next until it reaches the end of here. Then we will not be appending element to we will not be dealing with this linked list. All the elements in this linked list will be processed. So now the problem has been reduced to how can we find the smallest one among those. Let's say we have k linked lists among those k linked lists. So a natural answer is to use priority queue, because priority queue can give us the minimum mean heap, can give us a minimum of log k time. Then if we can maintain this and know how to move the pointers, the total complexity would be n times log k, because we will be essentially, each operation will take log k time, and we will deal with every node on every linked list, and the total nodal number is n, and the space complexity is on for the answer, ok for our priority queue, and plus some constants, like our answer we need to traverse. I think that's pretty optimal. Now let's look at our solutions, implementation of solutions. So first, let's create the container. So in C++, we can directly use priority queue, where the element is the least node, and let's define our comparator ourselves. We can define a struct called comparison, and within this I just define a Boolean operator where it takes two linked list node. Let's pass by reference, and I'll just return a value is actually bigger than b value. So now we have our priority queue. First step is to initialize our priority queue by loop through our linked list in lists. If I do have a linked list, I just push it to the priority queue. And let's do some edge cases. If my priority queue is empty, I just return a null pointer. Otherwise, we need to create a answer linked list which points to the smallest one, top, and I need to, at the end, return the smallest one. This is going to be our first element of our answer linked list. And I will create another one to traverse the linked list. And for each, if we know what's right now, we want to pop it, and then we want to check whether we want to move these pointers to the next one. So if it does has, then we want to push the next pointer to our priority queue as well. So after we initialize this, we do while my PQ is not empty. I always link my P next to the top, and I pop it. And then I move my pointer to the next. And if my P next still have value, I push my P next to our priority queue. Cool. Let's try and run the code. Seems to be working. Let's try to submit it. Cool. There is another version of merge k sorted array instead of linked list, but I couldn't find it on Leetcode. But there is a question on Algo Expert, which is another platform. If you don't know that yet, I'm going to make a video on that platform actually about this. It's very similar question. We are going to create a priority queue. We are going to initialize the priority queue, but instead of contain a linked list, we will use a different data structure for that. So stay tuned. See you next time.